Welcome everyone to the Dallas Personal Robotics Group Robot Builders Night Virtual for October 8th. We'll have the usual agenda. We've got a queue going, and people can tell us what they've been up to, and then we'll go to open mic. So with that said, is there anything else? For those, let me see. Just one item before we go to the queue. Oops. Hey Doug, are you on the line?
Yeah, I'm here.
Just want to, for those of you on the line who would often come to the physical meeting at the makerspace, just want to take a poll whether we should hold a meeting on October the 26th. That's the only agenda item I have formally on the agenda is to watch the Canadian division of DPRG run Robo Columbus. And I think you'll probably have 2 robots to run, right, Pat?
I will have one, and I believe Tom is working on his.
So
I'm working hard on it, and I have all my fingers crossed.
So, that's probably part of a meeting. We can probably pull together something else. Not sure what yet, but let me take a brief poll of those in the Dallas area as to whether we should have a physical meeting and see each other's happy faces in person and eat some pizza together, or do we not care? Yeah. Yes.
I plan to be there. It's one of the few weekends I'll be in town, so I think there's something positive to gather together and just, even if it's pizza, if we can at least agree on whether they have cheese or not.
Well, Doug already set the rules and said no white pizza.
Yes.
What's your take on it, Doug?
I like the idea, if we just meet and watch the competition and eat pizza, and if that's all there is, then we go. I think it's enough. Yeah. Even let's say Pat and Tom get done in 15 minutes. We can still eat pizza and talk, and we can. If you got anything you want to give away, it's a good thing to do.
Yep.
How
about we add on a show and tell for Robo Columbus? Talk about any new stuff, fancy stuff, whatever that you've got on your Robo Columbus robot for anyone that's going to compete out at Steve's.
Good idea. Let's do it.
All right.
Plus we can
declare that done. All right. Next up, Kareem is at the start of at the head of the queue. So, Kareem, take it away.
Okay. Why won't it let me? Choose a tab. Don't let me do that. Let me try it this way.
So the meeting that we were going to do is for the 26th?
Yeah.
Okay. Sorry.
Yeah, I was telling Pat, Carl, no, sorry, Harold, I'm heading off to New Zealand on the evening of the 26th. So I hope my wife will let me attend, but I better have my packing done before I attend.
Okay, so we are going to see the unboxing. Oh.
Well, I recorded it. It's not live.
Oh, okay.
So we can skip through it real fast. But yeah.
Okay.
So yeah, I got this row arm today via Amazon, and the box does not have any sealing tape on it. So I'm lucky that I think everything arrived. So you peel it off, and this is what you see. So it comes fully assembled. So various bags of parts. I think this one is extra attachment plates and some hardware. That's a standard screwdriver that they provide. More different kinds of attachments, USB cable, nuts and bolts, that kind of stuff. Rubber bands for tensioning it against gravity. A 5 amp 12 volt power adapter. And that's the arm fully assembled. I wonder if I can point out some things real quick. Go from this point of view. So there's actually, let me go better angle on it. I didn't give you that angle. Okay, so there's a base right here. So this is entirely servo-driven arm. There's a base right here. There's a Lazy Susan bearing right there to support it. It's supposed to be able to go 360 degrees, and it does. There's a shoulder joint right here. It's actually got two servos ganged together. And these are all their own brand. This is the Waveshare serial bus servo brand. So these are just helping increase the torque. And then the elbow is up here. That's a single servo. And then there's another servo here with the gripper. And there's also an LED light that you can turn on and off coming
like
out of it.
Serious gripper.
When you said it could rotate 360, can it do continuous, or is it just, otherwise does it hit a stop it and have to turn around the other direction?
So the servo itself can do continuous motion. I believe it can do up to 5, but it doesn't have a, the wires are going to get wrapped up.
Gotcha. Okay.
Yeah.
I didn't realize it had an arm, Kareem, because your post on Discord just talked about the platform, the mobile platform.
This is something that I added. I think I posted somewhere around added. So I've added notes for this to the bottom of my Waveshare notes page, and I did reference it earlier this in the week. But yeah, this is a totally separate product. This is actually twice as expensive as the Rover. This is a cool $200. A little bit more than that. It's like $190 if you buy it from China, but with the shipping, it's probably more expensive than Amazon. So on Amazon, it's going for about $225 right now, and came in 2 days. So so let's actually see it in action. I've got more like unboxing, laying out the stuff that's in those bags and stuff like that. But I don't think anybody wants to go through that right now.
That's cool how they've got a 2020 extrusion as the first part of the arm. That's kind of neat.
So it's not actually a 2020 extrusion. It's two separate extrusions. I think this is a European standard. It might be a 2020, but it's not square profile. It's two rectangulars that are separated.
Ooh.
So
okay, so is it 2040? Or are you telling me like that? Or?
No, it's not a 40. It's more like 2010.
Okay.
Two 2010s, if that's a. That looks about the size, actually. Yeah. Do I have an angle where I can show that? Yeah, here. Yeah, there you can see the gap between them. And this is a carbon fiber rod, and the wiring does go through the carbon fiber rod for that last segment.
That's pretty cool. It looks like they they thought out of the box a little bit on their materials. And
Yeah, yeah, it's not. I mean, for $200, it's pretty amazing. So let me also point out that there's a that's a little Wi-Fi antenna. So this has the same. This is driven by the same driver board
yeah.
that I've been talking about for the other robots, the WaveShare board. This is the
Mhm.
general driver board. That's the Wi-Fi antenna. That right there is a tiny little OLED display. And so it boots up out of the box with a Wi-Fi interface.
Mhm.
But you can also, there's a whole ROS 2 project behind it as well.
Whoa.
So, and it comes with this handy little desk clamp.
Mhm.
So I guess it doesn't mount on the rover. Is that correct?
It can. You'd have to take it off of the desk clamp. That's what some of
Yeah.
those extra brackets that it came with are for. So I wouldn't mount it on my rover. Here's my rover.
Tip it over.
Yeah, my rover's a little bit on the small side, but they have those slightly larger UGV 6-wheel ones where they show people mounting the arm directly on it.
Oh yeah, because I thought I looked at that 4-wheel one that you got, and it didn't seem like it would be proportionate to the size of the arm that you're showing.
Yeah, no, this is a pretty large arm. So basically, the radius of it is half a meter. So the diameter that it can reach is a full meter. And it's supposed to be able to fully extended, be able to lift about a pound.
Oh.
So, and now it's still hobby, slightly better than hobby level servos. So there's a lot of play in it. It's not super precise. It's not what you're going to get with a real professional robot arm, but that's a really low cost way of getting into arms and still have a chance to get exposure to how move it to, and RAWs, how people tackle kinematics and stuff like that in RAWs. So it's pretty I'm pretty impressed.
Okay, there's got to be one question.
Yeah.
Is this FTC legal?
No, absolutely not.
Okay.
For FTC, first of all, you can't have extra controllers.
Yeah.
There are no extra programmable controllers. The servos that they support are only the standard RC style. So
Mhm.
pulse width modulation, the serial servos, they're not supported. And you can't buy anything off the shelf that's more than 1 degree of freedom.
Huh. Well, okay. That kind of fails on everything.
Yeah. This is not for the team.
Yeah.
Okay, so Kareem, if you
Mhm.
clamp this to the table and have the end effector grab the joystick on an RC controller for a robot, would that count as teleop?
That's a good question. That's a real good question.
And then you could use computer vision to like guide it. So that would there ought to be a Rube Goldberg division. I'd like to see that. Can you have that whipped up for I don't know.
I don't think that's a demo I'm going to invest a lot of time in.
Oh, yeah.
Unfortunately.
Yeah. It would be cool, wouldn't it?
Yeah, it would be cool. So I'm going to actually show you the robot. Or the arm. So you guys can see that?
Yep.
Yep.
Is my audio still okay?
So far.
Okay. All right. So I'm connected via my laptop here over Wi-Fi to it. So there's no RAWs, there's no host computer in it. I'm just doing the built-in web interface. So this section up here is controlling the joints individually. So this is the base right here. Right there. If you hit init, it goes to the initialized power on position, which is like that. So this is a shoulder. That's the elbow going up and down. And this is the, can we see the gripper opening? Yeah, we can see it. Let me go. So there's the gripper opening and closing. So it's just a single side paddle that opens and closes. Who's eating the chips? Is that Ray?
Nope.
No?
No chips here.
Somebody's crinkling a bag of chips. That's what it sounds like to me.
I haven't heard any of that.
It
Huh,
might be
interesting.
feedback. So let's until we can stop driving Cream mad, let's all mute unless we can say something. Because it might be feedback too.
Kareem,
Yeah.
is there a wrist?
No, the gripper is the wrist, if you like. And we could add more onto it if we needed to. That is so weird. I keep getting this crackling noise. All right, so you can also turn off the torque. So if I do torque off, then now I can move it just fine. I can reposition it, right? And then I can put torque back on, and now it's going to hold. So this is the amount of play that you've got in it. It's quite a bit. This DEFA off and on, I have no idea what that is. You know, I just unboxed this, 20 minutes before. Here's the LED turning on, off. Here's where we start getting into the inverse kinematics. So these are actually backwards. This one that labeled vertical drag is actually going to be horizontal. But if what it's doing is it's keeping it the same height going across the desk, right? And the neat thing is that if you go past its set point, then it automatically turns around and keeps on going.
Nice. Nice.
So it's true inverse kinematics. Whoops, don't want to go that way. It'll hit my laptop. So back out of that. And then you can also control the joints. You can control it here as well. So this is X. So it's just going, and this is Y is actually, why did it go out that way? That's more like Z. Oh, okay. So Y is actually keeping it, is the base turning. I guess that makes sense. And then Z, or it's just the X and Y axes, basically. Z is up and down, but I don't know if you can tell. I guess I'm actually off screen at the moment. Let me go back to init. But while it's doing this, it is this is going straight up and down, but it's going forward and then backwards to keep the curve out, right? The section down here is where you get access to the JSON text command API. So you can just type your commands directly in there. And then you can hit send and send it to the robot. And at the bottom, there's a whole section of different sample commands that you might send. So it's sort of self-documenting. So here's torque control, dynamic adaptation. So I think it has, like, you can control how much force it's going to try to produce, which is something you're not going to get with regular hobby grade servos. There's movement control commands. So, and this is just, this is with the built-in ESP32, just responding to those JSON commands. This is before you get into any kind of RAWs control over it. So that's all I wanted to share. Seems like a promising platform for the price.
Yeah, it seems well thought out. I've been impressed by the WaveShare products that I've had.
Yeah.
They do a pretty good job. When they get lost in the weeds, though, they really get lost, because usually it's something nitty gritty. But overall, they're good company.
Do you have the WaveShare rover anywhere convenient that you could show Kareem? I don't know if you've shown it previously, but okay, cool. It's actually off screen at the moment. Cool. Thank you.
So this one has a Raspberry Pi stacked on top. That's an NVMe board. To make it go a little bit faster. There's the little OLED display right there. It's normally over here, so I haven't, So again, this is a pretty small unit compared to the ARM, right?
Yeah.
So I wouldn't try to mount it directly on here, although it does have the same patterns, so you technically could, but it would be pretty topsy-turvy.
Cool. Thank you for showing that.
Sure.
Excellent. Well, thank you, Kareem. Let's see. Next up, and I guess just I lost my place. I don't know why.
Harold was next.
Yes.
All right. I've unmuted my mic, so watch out. So you might have seen some things I posted up. It's something called Tac Attack. And how this thing got started was I've got a bunch of those TT motors and other motors that don't have encoders, so I couldn't tell how fast things were going, and I wanted to get speed of my motors, and I said, well, I could do a couple different things. I could get a I could pay $45 and get one that I looked at a few of the electronics sites that dismantled them and looked at them and put them on, and they were kind of sketchy at best on what they actually reported and how they reported it and things and that kind of stuff. And I'm like, okay, well, maybe I get a good one, maybe I don't. I'll probably get a better one now than what they did, but whatever. Or I could, I looked at how do you build it yourself, and effectively, it's an Arduino Nano, it's an OLED screen, an infrared transmitter receiver module, and a few bits of wire. And I'm like, well, I should be able to build that. And not only should I be able to build that, but I could make me a PCB. And so I went through all that kind of stuff with the KiCad and the PCB. And of course, the first one, thanks to Doug. Thanks, Doug, for jinxing me, because the first one, let's just say there were some things wrong with it. My nets weren't set up correctly. And so I had a constant on power instead of, it routed power the right way, but didn't go through the switch first. So as soon as you plugged in the battery, it was always on. I took a little, and I got 10 boards that are like that, and I can fix those with cutting some traces and doing a patch. The other thing I've got, then I fixed it, and now I have 10 more boards. I'll show you up another one kind of closer if you want.
Yeah.
Here in a second.
Let's see.
And I'll do a close one in a minute so you can see it up close.
Yeah.
And I got 10 more boards that supposedly has that fixed, although I haven't put power and chips and things on them yet, because I got into doing models of how I want to do the thing. And I could have just made a box or some blobby thing or some other thing that people do, but I wanted it to be fun. And so this is what I came up with. You're seeing my prototypes here. The first prototype I've actually thrown away because it was a piece of junk that I downloaded off of Thingiverse, and I had to split it up and try to make a model. And I don't know what they used to create their STL, but it was pretty trashy. So after banging my head, I threw it away, and I first developed this thing. And you can see the progression as I was going. You'll see some extra holes and stuff. This is some initial layouts where I modeled this thing up. And if you haven't recognized this yet, my inspiration was Star Trek: The Next Generation, and this is a Type 2 phaser. Okay, there's I got a few different ones. I picked up some ones. I got a boomerang one. That's one kind of thing. But this is the one that kind of fit what I had going on, and it would fit the board the easiest on doing things. So I went through several of these iterations and finally got to one I thought I liked well enough. And it's got a little snap fit, which the jury's still out on snap fitness and how much I'm able to do those. And I'm putting labels on them. I got them embossed. The whole works. And I go, okay, this is good enough. So let's go make a real one. And I say a real one. Let's go do some finishing touches. And I came up with this one. And this looks finished, but it's not. Because my snap fit tabs here, because the way I printed them, this actually wanted to print best flat, even though it's got some nasty stuff over here. And this one wanted to print vertical. And that's cool, but the snap fit snappers have layer lines that go right across them. So as soon as you put any pressure right here, it just snaps them right off. This is all matte PLA, by the way, because I like the colors of the matte and tried to mimic some things so it looked kind of like a cosplay prop going on there. And you can also see the different. If you look at the this is the same color filament, but because it's printed in a different orientation, the colors are way off. And I'm like, I don't like any of that. So we printed it. I made some modifications here, printed it again, threw some electronics on it, and now this is what we have. I got my OLED screen. Now all of this is an MVP. There's a few things I want to fix on it, but I'll go over the features and then we'll open it up. First off, you got a switch here to turn the whole thing on and off. I still got to put electronics in here, but I got something just kind of placed in here, and I'll open it. And then you got to wait to take a reading. Not sure what's going to show on the screen yet, but I got an OLED screen. You have two little dots that maybe you can see. One of these is power, and the other one lets you know when the IR sensor is triggered. And you got a hole right here. You got a screwdriver to adjust the potentiometer of whatever you're about to trigger on. So you can adjust the thing so you can see, oh, I'm triggering, cool. Then now I can rotate it around and hopefully I'll get me some data. Oh, by the way, this is one of the first prototype boards that I put together. And this is one of the ones that's busted. So I've got all the stuff that actually works inside of this thing. If you'll look at this, see the same color check as we go through. Same color all the way around because both of them are printed vertical. It caused a lot of support.
What are those things?
They're support. Those are things. This thing is printed vertically. Here, let's see if I can do this over.
I saw them in your Facebook post, and I was like,
this thing is printed vertically like this.
I have
And
never
what
seen
happens is-
support that look like that. That is freaky.
What now?
I said I have never seen support that look like that. That looks kind of freakish.
It's called tree support, and the idea is that it uses a little less filament and can, as you see how it kind of gets routed around into things and that kind of stuff, so it can go into places and around things and up over the things where the support actually needed, where the standard square top support is difficult for it to get to. And you see how it kind of branches off.
Yeah,
I got a bunch of them. It also
did your slicer generate that?
What now?
Did your slicer program?
Yeah, the slicer. I've got an A1 bamboo A1, which comes with its own slicer thing, but every slicer out there has ability now to do tree support.
Really?
I think it's really PERSA. I mean, it's a modified version of PERSA.
Yeah.
Oh.
Most of the slicers out there are some fork of Prusa. Well, the Cura is not. I don't think they did their own engine, but a lot of them are using off Prusa, where they got their ideas and they forked it off and did their own thing. And so, and this tree support's been coming for a little while. There's another pretty good example of it. And it's literally a tree. And this stuff just literally snapped right off. The other thing that happens, you see I've got colors. Well, in order for the thing to change, it does its own color. I used the Bamboo Studio to color all the bits and pieces all the way I wanted to color. And even though it's using, it almost took 400 grams of filament to print this thing. Between the support, the purge poop, which I got a bucket over there I can show you, that it changes the filament out, so it runs a bit of filament out. Make sure it cleans it, it cuts it off, runs some of it through to make sure it gets all off, then runs the new filament in, and then spits some more in there to make sure it's got a good clean run, and then goes back and prints whatever it needs to print. For this print, it was about 630 to 650, I forget the real number, filament changes. And guess what? I didn't have to do a single one of them. It did it all by itself. It did take 23 hours to do, though.
Do you have the 4-spool filament holder?
Yeah. And it did take 23 and a half hours or so to do it, but that's okay because I kicked it off and I went to bed and went to work and whatever else happened. Right.
Wow.
So where was I going with all that stuff? So I did print some stuff. So if you look real close, I colored up, and the lighting on that isn't great. Let's see if we can do it the other way. That's actually not me coloring it. That's the filament being distributed like that because we embossed the text into the model. This is all Fusion 360 stuff and OLED, right? You switch on, switch off, and the snaps are better because I changed them, but I am still it's out a little bit. I got jury's still out on that. I have a charge board down here where you plug it in. I've got a LiPo battery that fits right in here, so it charges the battery, and then when it's not there, it powers the board. You may say, well, what board do you have, Harold? You said you were going to show it. You hadn't showed it yet. I'm getting there. This is the board I came up with, and I've already decided I do not like the white on black. I thought I was going to like it, but I don't.
I like the traditional green.
Yeah, I think I'm definitely going to go. I'm going to go to a darker color on this. I wanted to do these purple, but that took the $5 for 10 of them and turned it into $38. And I'm like, no, I'm not doing that. Maybe on another one. So I was able to lay out the thing using KiCad. There's a button to say click, send it to PCB way. Most of the stuff was filled in. I checked a few things, had to read some stuff, and got it. Also, so I got my name on the back there, and what version of it is, and those are kinds of stuff. This does a really good job of fitting into this. Not satisfying kind of sort of click on that. And then I do believe I got to test to make sure, but I think I'm going to have to solder the board right to and not have a jumpers off of it because of the distance and things. But I wanted to have I want to have something fun, and I wanted to have and test some skills. I learned a bunch of stuff I didn't know I needed to learn. And again, this is all matte filament except for the very end there. And I like how the look happens. And you'll see something else too that was not anticipated. You'll look, you see I've got slices in this tip here. Not supposed to be there. I just ended up making those walls so thin that my slicer decided to take them out and not even try to print them. I like the look, but that was not what was intended. Let's see what else. Yeah, and if you didn't see, in order to make these colors work, and it has to spit out so much filament to make sure things are clean. Some of it will go into this. If this is part of the filament, it's going to be squirting out. If it thinks, I told it to use. You can purge the filament into supports or infill. So if it can purge all into infill, it saves you a little bit of time because then it doesn't have to build one of these, which is something called a purge tower. So if you'll line this thing up, you'll see how it lines straight up all the way up to play about what colors went on what levels and what things, and it keeps track of it. So it has to build the purge tower, even though like right here, see this big thing here, it didn't need to do all of that, but it had to build it. Well, that's not exactly, because it swapped between the lines, but like that section there, it had to build it even though it didn't need to swap, because when it did need to swap, it needed a place to set it down and then to swap it to. And the Bamboo Studio did all of this. It allowed me to paint this stuff, and the painting was actually a lot easier than I was going to be, because it's got the idea of, like, you have your paint bucket where you can fill areas. The thing is smart enough that when I clicked right here, it knew to fill out this whole section, and I filled out this whole section. I turned it over, clicked here and there. I did have to click on the edges because it knows about the edges to fill it all in. Where it gets a little bit wonky is when you start talking about this place is up here, and then I had to come around the edge and fill in some. Well, this I didn't do it on that one. I did it on this one. I had to start filling in the edge here to get the black all in here, because I decided I want this to be completely black, and I just couldn't click on this edge here and have it do it, because if I click on that edge there, it colors all of this black, and that's not what I wanted. So it was a bit funky to mess with, but it was able to do it. I was able to do it. It didn't take very long to figure out the thing, some of the painting, and then I had to literally get a paint brush. It's just a circle that I made really small, and brush on that part there to get it. And then once I did that, the slicer figured out. It says, "Oh, you got 4 colors. Got that. Tell me when you go to slice, if you don't have it set up properly, it asks, okay, for this color number 1, what spool do you want me to use?" And then you just select all those things and tell it to go. So at some point, if I wanted this thing to be red, white, and blue, I didn't even have to reslice it. I just hit the button to print again. And when I go to print, it says, "Hey, I don't see these colors. What would you like me? How did you want me to set them?" And it's truly amazing on how much work that this thing does for you that you don't have to do. For instance, one of the things this Bamboo does, and I think most of the other printers are going to be doing all this anyway. Not only does it level the bed, it also does a vibration shake test, so it knows the resonant frequency of your printer every time it goes to print, so it can go as fast as it possibly can, and taking your resonant frequency into consideration for the jerk and acceleration and all that stuff. It applies to it. And the other thing that it does is it makes sure the filament's backed out and put in, and does a bunch of stuff that every 3D printer probably should do, but I'm lazy and I never did until it broke, and then I fixed it, and I did, and then I didn't do it again until it broke, and I fixed it again. But it's doing all those things for me as I go, and I think it's really cool. And for right now, I think they got them a combo unit, the printer and the 4-channel AMS. It's like $489. You can get them in Micro Center. And I'm like, this is, as much as I liked all the other printers that I've had, this thing is as close to take it home, set it up. There's 12 bolts to bolt in, and a couple of setup things. It's even gotten up and told me, "Hey, it's time to oil your Y-axis. We give it that oil we gave you in your package, in your thing. Get some of that oil and apply it to the Y gantry, because you've ran it enough to know that we need to put some more oil on there." It keeps track of all that stuff, and of course, me being lazy, never kept track of any of that.
Harold, which model have you got?
What now?
Which model of Bamboo printer have you got?
An A1.
I am really impressed. I've just been looking at the prices. Maybe it's time for me to buy a new one.
Hey Harold, what's
Yes,
the
sir.
principle of this thing measures RPM on a wheel, right? What's its operating principle?
Okay, so what happens is, this is a module, right? This is an IR module, and I got an Arduino Nano on the thing, right? The idea is this thing blows out IR and receives it. So you're going to need to get it pretty close for that signal to bounce in and back out. And a lot of times, like for instance, when I was measuring, I think we were using one of these wheels here to do it. I just put a piece of tape across it. And then what happens is every time this thing fires, I get an edge.
I see. So it's
And I wait
counting on one.
Yeah, and I wait till I get the next edge, and I get a time period that the thing went around. Do the math.
Yeah, got it. Thank you.
And so it's relatively simple, which is why I wanted to make my own PCB, because there's really only, I don't know, there's probably not even a dozen traces on this whole board. Most of this is just ground plane on the thing. And I figured I could figure that out at least. And when I screwed it up 2 or 3 times, at least, it'd be easy to debug and figure out some other problems with it. And yeah, I've screwed it up at least once. I've not tried this one, Doug, so it may be screwed up too. So I might have to do a third one. You may be right.
No, you probably got it. Yeah.
But if you go look online for all these people that done the tachometer stuff, they use these all the time.
Yeah, that's the basic sensor that I used in all my beginner classes.
Yeah.
Because you can take those, you can make other sensors using that module.
Yeah.
It's very flexible.
You can use it as a proximity sensor. So if you get too close to something, it goes off, all those kinds of stuff.
Drop sensor.
Yeah, all that stuff, right?
Yeah, there's a whole bunch of things you can do with it.
And with the potentiometer right there, you get to control the sensitivity of how much power you're putting out. So what you're getting back. So I bought like 20 of these because I got them in a bag, and I looked at the shipping, and I go, well, if I buy 2 of them, shipping's going to be like 10 times the amount that I'm actually paying for the stupid things. So I bought enough where the shipping was about equal to what the stuff was that I was buying. So, so I got a bunch of these. So my plan is to, when I actually put these together and prove that it works, and I get the GitHub out there, that I'm going to put all of these I'm going to have a kit of parts, because I got a bunch of these nanos still hanging around and some other stuff. I'll put them up there and sell them. I might even print out some of these cases and sell them too, but at a 23-hour print, I'm not sure how much I'm going to charge for that sort of thing. I'm not looking to make money. I'm just looking to recoup, costs.
Yeah. Hey, Harold.
Yeah.
But the reason you printed it vertical was only because of the tabs?
No, the reason I printed it vertical, the really reason I printed it. So let's take this one that I printed horizontal. This was printed horizontal, and this was printed vertical. Same bottom half, right? I did make some changes, but the tabs was one of them. But if we turn it over, this section right here is not flat on the plate, on the build plate. And if you'll look at the quality of what I've got, even though I had support and stuff on it, I don't know. Yeah, there it is. Let me get closer to that. See, you see what's happening there? You got all those striations and that stuff on there. That's what you got. You can also see, this is actually a cool part. You can see it looks like a finished part here because the way the plate embedded itself on it. Compare that to the one I printed vertical. It's smooth. It's smooth up and down all over the place. The other thing, and you can see that same indentation on what came off the build plate on that. The other side of that, the top. Here, we'll use the top one here. This was printed vertically every time, and so if you look at this, you see how everything has got a nice smooth gate to it, nice full level to come up. The ones that I did not print that way, we'll print one of the final ones that I printed. I printed laying down. If you look at that, you see the stair steps because of the angle.
Where's that? What's causing that? Looks like a problem.
Yeah, well, it's really, I printed this flat, and I didn't care about what the inside looked like, right? Because the inside looked like crap, but I cared about what the outside looks like. What's happening is this is a 0.2 layer, and so every one of these stair steps you hear have is like a 0.2 layer above on either all of them, because you got an angle. It's not able to make a smooth angle, and the angle is slight enough that you get a lot of the stair stepping that's going on there. If this was a 45-degree angle, you couldn't tell, right? Pretty much couldn't tell. But it's not. It's such a slight angle, so I can't tell you what the angle is on it. But
okay. You're saying that the model is angled.
Mhm.
Okay, I was trying to figure out. I thought it was supposed to be flat there.
Yeah,
It's not. It's supposed to be angled slightly up.
it's angled slightly up,
I got you. Okay, now it's making more sense, Jay.
and so that's just where all the stair steps come
Mhm.
from. And so, in order to get the nice smoothness out of it, this had to be printed vertical.
When you say vertical, do you mean like 8 inches tall?
Yeah, this is on the build plate. Here, let's see if I can change it.
Just put it on your blue plate the way it's supposed to be,
So
like that. Okay,
just like that.
okay, gotcha.
And this one with all the steps were printed just like that, with all the support underneath of it, which is fine. even though
You
looks
keep
like
it from falling over.
Yeah.
That's such an extreme aspect ratio. I would think that it would delaminate from the base plate and fall over.
Well, I got some tricks.
Huh?
First of all, I got some tricks. First of all, you have a bunch of this stuff.
Oh, gotcha.
You got a bunch of this stuff all in around it, and I forget where it fits in over here, but
Okay.
you know, it's kind of like that. Also, I got some other things too. Hold on a second.
I think Harold has a PhD in 3D printing.
He's getting there.
Thank you for the compliment, but not even close, Paul.
Yeah.
So this is the plate. This is the base plate that comes with the
Right.
A1. This is a PI infused plate that has some texture to it, which is why you see texture on the bottom here. This thing sticks really, really well without anything else on it.
Yeah.
And it's flexible metal, so after you pull it off the magnetic base, you can flex it. And it'll break your part loose, and it's pretty good. I'm more, well, see, I've got suspenders on, right? I got suspenders. Right. So I'm kind of a belt and suspenders guy on occasion, and this is one of those occasions. So this stuff is a little expensive.
Okay.
This is a 40 milliliter bottle. No, it's a 120 milliliter bottle. Costs about $45. I've been using this for almost 2 years. Almost. There's probably 300 plus prints in this bottle. You don't have to coat your plate every time, but it's a nano polymer adhesive, just like it says, from Vision Minor. And this is engineered
From who?
Vision Minor.
Vision Minor?
Yeah. Can you see that? Visionminor.com.
Okay.
Okay. And so this has been engineered for what we want to do with 3D printing.
Mm-hmm.
You put it on there, a nice light coat, smooth. They give you directions. It's literally you're running around, putting an X on it, and both directions, 2 directions. That's about it. And then once you do, you let it dry. In fact, a lot of times it's dry before you get done with doing all the things. Then when this thing cools off, the nano bits and parts in this thing totally relax and let everything go. When this thing is hot, you're going to be hard pressed to get this off the plate because of this adhesive.
Okay.
It's
Cool.
made it like that.
So you give that a recommendation.
Well, yeah, high recommendation. It's a little expensive, but again, this is a 120 milliliter bottle. It runs about $45 or so. And I've literally been using this thing for almost 2 years, a year and a half to 2 years.
It's called nano polymer adhesive.
Mm-hmm.
There's a link in the chat.
You put the link in the chat.
Okay.
Thank you for the link, by the way. But yes, I've used ABS slurry. I've got some hairspray still laying around here from doing that. I've got glue stick. I think I even tried the salt water thing one time. But whatever snake oil that was, this stuff hasn't let me down. I will tell you, do I get things lifting off? Yeah, I do. In fact, I'm going to be straight up with everything. If you look on this one right here, you'll see it lifted just a little bit right here over the course of printing. And this was printed flat because at the edge of the bed, things just got a little more worn than the rest of it. And it doesn't have any brim on it to help hold it down either. But it came off just a little bit. And it does happen on occasion. This is probably my fault because I didn't sluice it up in all the right areas because I was being lazy and didn't really check. I just assumed I got it all, and maybe I didn't get it all like I thought I did. But it does happen on occasion. That's an indication that you probably need to reapply some of this stuff, or you just miss it out just outright.
Okay. I was gonna throw out some ideas. This is a very intriguing project, Harold, and it's so intriguing. It just makes me want to throw out a few ideas, if you don't mind. I don't
throw away, man.
These aren't criticisms. I was wondering if you could. Why do you need the latches? If you need, why not just use a simple screw?
I could do that. In fact, I've already decided that if this is my MVP, my minimum viable product, and I got to finish putting it all together because the front end up here doesn't snap very well due to those LEDs are just too fat.
Yeah.
And if it tends to come off like that, I've already decided that I want it to be slick. Okay, with the snap fit kind of thing, I want it to be slick and cool.
Yeah.
And what I'm going to do if these tend to say don't work, I'm just going to turn it over. Where do we go? Yeah, this is the bottom and this is the top. I'm going to drop a bunch of, find out 2 or 3 places around here to drop a bunch of towers and make screws out of them.
Okay. And I guess the other thought I had, because it's costing you so much time, is the brown wood handle part.
Yeah.
Make it a separate part. That
could happen.
Clipped in or glues,
Yeah.
That way you wouldn't have to worry about the, a bunch of change color poop.
Yep.
And the time.
And it could be easy if you're looking here. There's a little bit of overlap here.
Yeah.
We could easily remodel this thing so that the overlap goes further this way and further all the way around. So you got a place to glue it.
Yeah.
Right. And the same thing that's the bottom, this is the top. Same thing with the top, it'll be even easier.
Yeah.
Yep, I thought about that too.
Okay, and it also looks, instead of the wood colored, the thing, it just screams, make me a TPU.
A TPU thing on there, so it's actually rubber gripping.
A little rubbery handle typey thing.
That's a cool idea, man. And in fact, what I can do with that is just not color this, let it print it normally, and then glue the TPU thing on top of it after we printed that TPU separate. And that might be a simpler way to go about doing that 2-part thing and not have to burn a bunch of this color.
Yeah. Anyway, that was a couple of ideas that I had, and I'm sure it sounds like you had them too. So
yeah, no, I can't tell you how much stuff runs through my head.
yeah.
I just don't have enough seconds or time or all that kind of stuff to go through here.
Harold, what material are you printing in?
This is all matte PLA. I'm currently using Inlands, which is Micro Center's house brand, and there's rumors about whose brand that really is, but it's rebranded somebody else's brand that Micro Center is doing.
Sure.
And it's on sale.
Does your machine allow you to change materials?
Yeah.
So it'll automatically adjust the settings for a different material?
Yeah, I tell it, this is a roll. This is a roll of, most of the time I'm printing, I've never stuck like a PET G and a PLA together on that, because that's probably not going to stick too well anyway. I have different kinds of PLA. Some of it's PLA plus, some of it's basic, some of it's matte, and I've got a shiny PLA and a matte PLA loaded up into my thing, and it knows by those settings about some temperature stuff and some flow things, because this thing uses like a linear advance on the extruder. So it's got some ideas of how the filament flows. And I didn't do any of this. This is all I'm using just the basic settings. And if you want to go change the settings and do other things and make your own flow calibrations, that there's places in there to do that. I just haven't wanted to spend the time to actually do it.
Yeah, it's really impressive.
Yeah, and the thing prints really, really nice. I'm really impressed by it, and as you can tell, I'm pretty happy with a lot of things.
Yeah, I went and had a look at my local reseller. He sells bamboo, but only the top end of their line.
Oh,
Anything else.
The X1C there, yeah, $1,500 worth of.
That's
US.
US. I'm paying Canadian.
Yeah, you're paying Canadian. Yeah,
Very, very cool, Harold. Very cool.
yeah.
Thank you.
Yeah,
I
Harold,
didn't run
I
on
thought
so
you were
long. I
going
didn't
for like a
run on so
leather
long.
grip on the thing,
That's
Whatnot?
great.
you know, instead of wood. But, you know,
That's
Yeah.
great.
That is a great idea. I hadn't really considered the TPU action on that, but because I hadn't printed TPU in a long time. But that would be a really cool thing, and it would be an easy thing to do to model up the TPU. And so that gets rid of one of my colors that I got to worry about, and would certainly speed up all of this up until I got to another section. It'd be a lot faster print.
Yeah.
Because
So
if
I
I
think
print
Harold gets a gold star for
oh well, thank you so much.
demonstrating
Because I just
the
so that,
robot arm.
just so I can
Oh.
finish, just so I want to finish, because I want to make sure that people understand
Sure.
this color thing. You're paying for it in ways you don't understand. I mean, yes, there's excess filament and that kind of stuff. You're also paying for it in time. Same basic model, one color, 4.5 hours. Okay. Multicolor, colored up, 23.5 hours. So
Plus about 2 or 3 times the filament.
the filament, absolutely. Yep.
Yeah. By the way, I you know, with your recommendation, I did go buy a bamboo printer. I now am a proud owner of a P1S.
There you go, man. There you go.
It's great.
Yeah, there you go. It's that printer's faster than I got an A1, and I can run about 200 millimeters a second or so, and I think I can push it a little bit above that. But you can run a lot faster than that.
Well, I'm not so much that as I wanted the ability to do some of the harder filaments.
Yeah.
So you know, I haven't tested it on any of the carbon fiber stuff because I don't want to do carbon fiber because I think it'll mess the printer up over time. But I did do, you know, it compared to my old setup, I did nylon a lot easier.
A lot easier.
A lot easier. It was very nice. I mean, my other printer could do. I had one that was set up just for PLA, and one that was set up for ABS and nylon. And what's the other one that's replaced ABS? I can't remember what the name of it is.
ASA.
Yeah, ASA. I like that better than ABS actually.
Yeah, I've never used any of that. I've only read about that. So I heard it's basically prints like PLA, but it's got kind of flexibility like ABS does. It's got a resiliency like ABS.
Yeah, it's nice. It's a nice material. Yeah.
Also,
It doesn't stink as bad.
Also, one other thing, I don't know when it's going to happen tomorrow. If you want me to let you know, I will let you know as soon as I know. But the biggest 3D printing Twitch streamer is coming through town. He left Washington a couple of days ago. He's going to end up in Salina, Kansas tonight, and he's going to come down here, and I think he's going to stop at Micro Center here. So if you'd like to meet Loyal Moses, heck of a guy, I will let everybody know because I'm planning on meeting him. I just don't know when he's going to be here. You're doing road things. He's meeting his streamers. He's meeting not his streamers. He's meeting his followers, and they're all having a wonderful time. And he seems like a heck of a nice guy too. So
Why didn't you post it to the email list, Harold?
Okay, I'll do that. I'll do that. And I don't know if I've
Cool.
yeah, it's been a while since I've done the email thing. I've been doing Discord for so long. I need to,
Oh, Discord works too, and one of us can relay it.
okay.
Okay, well, thanks for that. I
So
forgot.
I didn't mean to run on so long. I just got hyper and went going, and
Hey,
know, and
it's a cool project and looking really good, Harold. Well done. Good job.
thank you very much. Thank you very much.
And I meant to, but I forgot to wave the gold star for Kareem for showing us an arm moving.
Oh yeah.
And second, we have someone new, a visitor. So I want to welcome Trish Cook. Trish, our usual format here is various, however many of us who have made progress on our various robotic projects will share that with the group, share learnings, and then after we're all done, we do a roundtable. So when we get to that, please feel welcome to introduce yourself if you would like to, and if you'd like to get some pointers into the club as far as our email list, Discord server and so forth, send me an email to president@dprg.org, and I'll clue you in. We need to get it better documented, but I'll make sure you're hooked up. Thank you for joining us.
Paul, also the recording reminder.
Oh, yes. Just so you know, we do record these sessions. So if you don't want to be recorded, turn your camera and mic off. Okay, so I was up next, and I've had some success, which I'm quite excited about. I got a bot phone. So it's sort of like a bat phone, but it's a bot phone, and I'll show you how it solves a lot of the networking issues that you get that you run into when running outdoor robots, particularly things like the at Robo Columbus and the autonomous mower and so forth. So here is a block diagram of Mobot, the mowing robot, and the key part here, all the rest of this is sensors and other processes, but the key part here is the Raspberry Pi 4 Wi-Fi connected to the bot phone, which is just a regular cell phone. I use Google Fi, and they give you a free data-only SIM, but other carriers may have low-priced SIM cards, data-only SIMs, or you can get some data-only plans quite inexpensively. The point is that the bot phone is mounted inside of the robot and has a Wi-Fi connection to the Raspberry Pi, and through its cellular connection, you get access to the internet and to the Tailscale VPN, which I'll explain in just a sec. I tried to explain it a month or two ago while I was on traveling, but I felt like that came out garbled. So I did a diagram here to try and make it clearer. But what has to happen for this robot to work and use RTK GPS is it needs to get corrections, GPS corrections, so it can send messages out over its Wi-Fi into the bot phone hotspot, goes out on the internet, goes to the RTK2Go server, and gets its corrections sent back to it. But, and here's the key point, it also goes out through this Tailscale. They call it a tailnet. Tailscale calls it a tailnet, but it's really a VPN connection that puts the Raspberry Pi on the same VPN network as my laptop. And so the laptop has a wireless IP. It's on my home Wi-Fi network. So obviously there's a router and a firewall before I go out to the internet. Has a home IP of 192.168.15.172, just what it got from the router, but it has a laptop. It has a tailscale VPN IP of 100.113.161.92. So, and then the Raspberry Pi has a Wi-Fi network of 192.168.224.156. So you can see that's a lot different from the wireless from my home network, and that's just what the bot phone gave it as a DHCP IP. But Tailscale gives it a VPN IP of 100.66. something or other, and Tailscale makes, now, as you guys I'm sure know, computers can have multiple network names, multiple IP addresses, both on a single physical channel like wireless, like Wi-Fi or LAN, or on different channels. So what's going on here is the Raspberry Pi has two IPs coming through its assigned to its Wi-Fi interface. One of them goes off into the internet generally and can access, browse the web or whatever. The other one is a VPN IP that can talk as a peer-to-peer network to my laptop, irrespective of the fact that there are firewalls all over the place here. Firewalls in the T-Mobile interface from the internet to the bot phone, and from my home to the internet. And so that's the theory of the thing. I'm about to demo it, but are there any questions on the theory of the thing?
Nope.
Okay. So here we have this is my laptop XPS 15, and here's its Wi-Fi IP of 192.168.15.172, and it has a Tailscale network device that has that 100 dot something or other IP. That's the VPN. So anything you send out through that.
Hey, Paul, are we supposed to be seeing anything besides this block diagram?
I'm sorry. I'm sorry. Thank you. Let me unshare that and share a window there. Okay, you should be seeing. Yeah, sorry about that. Yeah, so the Wi-Fi network with your usual local IP from my home router, and the Tailscale is the VPN interface with the it's 100 dot something or other IP. Now over here, I'm just about to SSH from my laptop into, I gave it the name Mobot V, V for VPN. So we're SSHing, and we just right there went from my laptop out through my firewall, across the internet, back in through T-Mobile's firewall into bot phone, and into the Raspberry Pi, and it popped out on the Raspberry Pi's VPN interface. So now I can run ifconfig here, and you see that its Wi-Fi interface has a 192.168.224. That's an IP given to it by the bot phone DHCP server, but it also has the Tailscale interface, which has a 100 dot something or other network. So what I've shown here is the ability to connect in a peer-to-peer manner as if they were on the same network between my laptop on my home network and the lawnmower running around down by the lake or wherever it may be. And there's a lot of flexibility in this.
Can you go back to the diagram again, just real quick?
Yeah, sure. I'll jump right back there. But just to show that I've got a let's see, I had a just I was trying to, yeah, there we go. So this is a VPN I'm sorry, this is VNC running over the VPN. So I used SSH to launch the VNC server on the robot, and then connected to the robot with the VNC client from my laptop. So anyway, that's it's pretty cool stuff. Okay, so going back to the diagram. Let's see. Come on, share out. Share out.
Is there anything special about the bot phone, or is it just another Wi-Fi hotspot?
Just another Wi-Fi hotspot.
Okay.
So it's really what I'm showing here. Let's see, window. I want this. I want this. I want this window. Share. It's being a bit slow at the moment. There we go. Okay, so there's the diagram.
Okay, so Paul, it's an Android bot phone, I assume?
Yep.
Okay.
Yeah, there's nothing special about it. It would work with an iPhone or anything.
So it's got a data SIM card in it.
Yep, you could use.
It's only for data transfer.
Well, no, you can use it on a regular cell phone. I've done it on my.
No. What I meant was the SIM card is just allows you to transfer data. You can't make calls on it.
Yeah,
exactly.
No
voice.
Right. And now, so you just swapped out the SIM card in that.
Yep.
Is there an app that it has to run?
No, there isn't. And just to be clear, Doug, you don't have to use a data-only SIM. You can use a regular voice SIM. I was using my regular Pixel 7 for a while before I got the bot phone. The only reason to get the bot phone with a data SIM is I can get free data within my plan's limits. So any phone will do.
But I'm saying, I'm sure everybody here has a drawer full of old phones. So I mean,
yeah, right. Yeah, and so that's the interesting thing is you can find some pretty cheap data-only plans, typically offered for for modest data amounts on tablets and such. Of the $5 a month sort of for a few hundred megabytes kind of range. So anything like that is a hotspot, or if you have like a MiFi or any of those carrier hotspots, that would work as well. You just need something that offers a hotspot to the Raspberry Pi and connects it to the internet.
Okay, and so where this is, you got it as Tailscale. What is it? Tailscale VPN, but you actually said you were actually running the normal VPN for Raspberry Pi.
No, I'm using the Tailscale VPN.
Okay, so on the Raspberry Pi, you have the Tailscale VPN.
He was talking about VNC.
VNC, yeah. You're not using VNC, right?
I was running VNC with the client on my laptop and the server on the Raspberry Pi, just to show that it can run through this VPN and across this link.
Okay, so you don't need the Tailscape VPN then, do you?
Well, yeah, because you can't do
anything. How much does that cost? Okay, for the VPNs, they usually cost money. So how much?
Free. So
Really?
for a personal account, you just log in at tailscale.com, and they've got a real easy quick start, and it literally took 10 minutes to get started. They give you a URL there's like a script saying curl. So you go to installing on Linux, and for Ubuntu 22.04, well, actually, they've got it right there. Tailscale.com, install.shell, pipe to shell, and that does it all.
Yeah, and it looks like it's also got it for Bullseye too down at the bottom there.
Yep.
Like I don't have a Linux laptop, so I could use use another Pi.
Yeah.
This is interesting, Paul. This is really cool. This does solve one of the biggest problems of communication over distance.
Right.
Assuming Steve has good cell service.
Yeah.
And,
How many
and
towers
the other
in this
thing you get with an account is this. Let's see. Am I sharing this page, the machines page?
Yeah.
So there's a dashboard that you can log into, that you can get to from Tailscale, and it shows that Mobot V has this IP and it's connected. PyDog V is not connected. His last connection was then, and the XPS 15V is my laptop, and it's connected. So you get a dashboard, and there's a variety of different things you can do with the dashboard, but this is just
You
to
get
help.
25 devices for free,
Okay. And
or
you
at
can
least
get,
you do on Zero Tier. But I think last time I checked, Tailscale was the same.
okay, and then Tailscale will give you 3 different users for in the free level. I'm not sure why you'd have multiple users, but they do allow that. Maybe that's if I was collaborating with someone on Mobot. I don't know. Anyway, so pretty neat stuff. Just thought you guys might be interested because it's very applicable. The bot phone cost me $130 on Facebook Marketplace. It's an all used Pixel 6.
Yeah.
So that's all I had. So
There's no special requirements on the phone.
Nope, just all you need here is all you need is some way for the Raspberry Pi to get to the internet.
Okay.
However that may be. And all the magic happens in this Tailscale VPN cloud of hooking it up to the laptop and making them each look like they're on the same network.
Gotcha.
Irrespective of firewalls and anything that's in between. So anyway, that's my little show and tell. Let's see. We had Tom was up next.
Okay, just a couple of little updates. Last week, I took my robot, which is now working well in a wireless manual mode, out to the Battlefield Park, which is where we're planning to hold the contest. Because the Battlefield Park is a little different than my backyard. It's actually a whole lot different. So it's a good thing I went. I had designed and built my robot based on a 2S 8-volt battery power supply, which runs great in my backyard. But the grass out in the park is 6 inches high. That's bigger than my wheels. And there's ruts because they cut it with a tractor. So my poor robot really, really struggled. So goal number 1 was to ensure that it would run well, and I failed. So I spent a good part of the last week upgrading from a 2S to a 3S battery system, which requires a whole lot more changes than I expected. The battery compartment had to be completely rebuilt, and the H-bridge had to be replaced because it wouldn't handle that higher voltage. And I had to build a secondary power supply to make sure I don't overheat the existing 5-volt regulator that runs things like servos and micros. That's all working again, working very well. And I'm really pleased to say that my robot now has much, much more capability than it had before, although I have not taken it back to the park yet. Now, the second reason we went to the park was because I have to get some GPS locations now that I've decided where the cones will go. I'm going to share some stuff here if I can. Here and here. This was also my opportunity to learn a little bit more about GPS. I don't know a whole lot about it. I do know that it has some accuracy problems. So I thought what I would do, you can see that picture. I thought I'd do was conduct a little bit of an experiment while I was out there. So I have 3 points which we've picked in the park, and this was a chance to go out and look at them up close. I took 4 different GPS devices to get GPS measurements from them, just to see out of curiosity what would happen. An old Garmin, 2 hiking GPSs, an old Garmin e-Trex, and a not quite as old Magellan hiking GPS. Took my my good old Google Nexus 5 phone, which is a great phone, and used it to collect GPS data, and my wife's Apple iPhone, an iPhone 11. So we collected 1 GPS sample from each of these devices after making sure that they were all reasonably happy with their satellite views, and collected that information at each of the 3 locations where we were going to put cones. The photograph, the satellite view on the right, indicates where those locations are. The red lines, this is location number 1, that red number. This is location number 2, and this is location number 3. Those locations are roughly about 100 yards apart, 100 meters apart. 1 and 2 are line of sight. Point number 3 it's line of sight from one of the areas, but not quite line of sight from the other. So I think it satisfies sort of some of the task objectives of the competition.
It looks good. I guess the question I have, Tom, is you're not over just running on the actual course, are you? You don't want if you're practicing, just to be fair to Pat, you should not run on the course.
Oh, okay.
Well,
My first attempt wasn't running anywhere, but
yeah, but you know what I'm saying is
I know exactly what you're saying. Yeah.
Yeah. So I mean, you can run. I can see several places you can test similar terrain.
Okay.
I mean, you know, they got that big field. You know, you could run around in there all you want.
Yep.
And over on the other side.
Those are good points. Yep.
But
So let's have a
don't
look
run
at
the actual course.
So let's have a look at the picture on the left. This is taken by plotting the 12 GPS measurements I got onto a tool called GPS Visualizer. The background map it's using is OpenStreetMap. You'll see a cluster here. This is point number 1, cone number 1. This cluster here is cone number 2.
Excuse
this
me.
marvelous
I don't
collection
see
is
any
cone number
cluster.
3.
Where's the clusters now?
I'm circling them with the mouse. Can you see them?
No, what you always see is a blinking hourglass.
I see it.
I see it.
Well, wait a minute. Go ahead. Do it again. I see it now. I saw it.
So that's cluster.
Oh, gotcha. Okay. I was looking over at the map.
Yeah.
All right.
This is cluster number 2.
Mm-hmm.
And that's cluster number 3. I wanted a better tool than Google Maps to hopefully to get a little bit
What
more.
did Google Maps?
Hopefully to get a little bit more analysis of my GPS data, which is why I used GPS Visualizer, because it came up when I started to look for analysis tools. It's fairly easy to learn how to use.
Mm-hmm.
Okay, so this does not look promising. I left the red track in place because it helped me understand the order in which I was collecting the data so I can tell them apart. So let's take a little closer look at what we've got here. The cluster on the left, that's point number 1. And you can see the 4 different collection points from the 4 different devices. That blue vertical line is 44 feet long.
Yike.
Yeah, that's what I said too.
Let me ask you this, Mike. Which one is the iPhone?
I'd have to go back to my original to find out. My concern was the outliers. For instance, that outlier is the Android phone. That's not quite an outlier. That one's the Android phone. And the one over here that I left out is the Android phone. So these others are the iPhones and the two hiking GPSs. I know which ones they are. I just can't tell you. I can't answer that question on this map right now because this is a static display.
Yeah, I get it.
So it'll pop up. So the center one, this is point number 2. I left out this outlier. This blue line is 64 feet long.
Mm-hmm.
Point number 3, I left out the outlier that's way off. It's off in a creek, actually. It's a long ways away. So this is a 37-foot long vertical.
Mm-hmm.
So this was extremely interesting information. Not really good from my point of view. So I'm going to do a few more tests the next time I go out to the park. Thank goodness the park's only a couple of miles away from where I live. I'm interested in taking more samples. I also want to pay close attention to the error assessment each of the devices has at the time I record these.
Mm-hmm.
All I did when I originally went out there was made sure that the devices had found enough satellites and that they were happy with measurements. But I didn't pay a lot of attention to what their actual error numbers were. All I knew was they probably had 6 or 7 satellites in view with solid signals. And I was happy with that, and they were happy with that. But I'll pay more attention next time. I want to
You
get more
also probably ought to try Google Map too.
and I want what that number would be, and I can easily acquire it and add it, right? Because I can get that at any point.
Yeah, you could just set it out there at the location, and then do a, what do they call it? A pin, I believe they call it a pin.
Yeah,
You get a pin on it, and then just read the GPS from
yes, it would be interesting to add. I'm not sure whether you can make any claims about improved accuracy, though.
No, well, I guess the argument, I would say, how long did you let them sit there?
I probably spent 5 or 10 minutes messing about at each point while I was doing the GPS collections.
So
It's kind of awkward sitting on damp grass.
Did you like map 10 minutes worth of data to see how much it was moving around?
No, and that may be one of the next steps I get. If you'll see number 3, okay? Number 2 first, though. None of this includes the GPS on the robot, and I would like to add samples from that GPS as well. So I have to get that configured so I can do it as part of this test. And finally, as you pointed out, I'd like to get more samples, in particular time-lapse samples. Not only how do these things look at an instant in time, but how do they look if I collect a sample every minute for an hour? I'm not sure how to do that. Is Corinne still here?
I want to say there's some software.
You had done some work and showed it a few weeks ago with regards to RTK. Was there some special tool you were using to show that mapped data?
So the data that I was using was 2 different things. I was showing uCenter, which is the uBlocks standard desktop app that is specifically to support their devices. I don't know if it'll work with any old devices. So it's for the GPS RTK stuff.
Probably if it was based on that part, but otherwise probably not.
Yeah.
I'll have a look.
You had one
And then I think I was also showing Google Earth as a great way to check on stuff and take my my logged readings and just for visualization purposes. You will find some weirdness with it in terms of trusting the alignment of the satellite imagery with the actual locations at different elevations, and the fact that the satellite photos are taken at various angles depending upon the view of the satellite at a particular time of year, and so particularly vertical things will have a parallax problem associated with them, and I haven't got to the point of sort of being 100% satisfied that their registration to the ground plane to the local elevation is 100% perfect, so that you know, even though I can find and the only way to do that would be to find a real GPS marker, you know, that like the city has put out, one of their medallions, and find that, but they tend to be too small to show up in Google Earth unless you have a really good landmark nearby. So yeah, I don't know how to like if you're trying to get within you know, centimeters of something, then
Well,
you know,
there's
but
no way
you're nowhere near that with the
there's no way ordinary GPS is going to get me that kind of resolution. But
No,
I would have
exactly,
I
yeah.
would have thought that I could have got within 2 or 3 meters, and I'm not.
Well, are you 100% sure that the Android phone was actually using GPS and that it has an actual GPS chip in it? The lower end Android
The
phones
short answer is
just
yes, it does. Yes, I
simulate it.
verified that, and it does.
Okay, all right.
Oh, they just use triangulation from tower.
Sometimes they just use tower
They
triangulation.
use
and they mock
they
that,
use
yeah.
power triangulation to try to improve their accuracy based on what I read about that device. But I understand it does have a GPS receiver logic on board.
Okay.
It has
Are your older handheld units just GPS or are they GNSS?
No, those old, the E-tracks and stuff are GPSs. That's what, so they're, and the iPhone itself is a GNSS. So that's why I asked, you know, the GNS, I mean, the iPhone should be the most accurate. When we do the measurement on Steve's property, generally we go around the course twice. So we check the home cone, we check the target cone, we check the challenge cone, then we go back to the home cone, then we go back to the.
You hit all cones twice.
You know, I hit each cone twice. And usually, you know, if they're off in the last digit or something like that, they're very close. And that's why also the rules say that the cone is located somewhere in a 10-meter location, because that makes, you know, we're saying that basically it could be anywhere in that 10 meters.
So you're using an iPhone to do the Dallas measurements?
Yeah, sometimes we use 2 phones.
Okay, good. That was
Yeah.
one of my questions.
Yeah.
The people who ran robots last year at Dallas, there were 4 of you. Were you using waypoint measurements for your course traversal? And did you have any observations relative to the accuracy of those waypoints relative to where the cone was? What was your experience?
We had one person, and I think it was you, Ray, who did his own cone waypoints.
Yeah.
And he had to change it back to ours.
I did my own cone waypoints too. I was using RTK GPS, nominally RTK GPS, but my antenna had problems, and I ended up having to sit it down on the robot, which made it not stay in RTK. It would kind of drop in and out of RTK and fixed an RTK float. So I really can't say that I was in RTK fixed the whole time.
Yeah, but you ran over the cone, didn't you, Paul?
But
I ran over the second one, but I missed the first one.
let me get some clarification, Paul, from what you said. Which GPS cone measurements did you use? Ones you got yourself or ones you were given?
Ones I got myself.
Okay, and you got them using RTK or GPS?
Using RTK.
RTK, yeah.
Okay. All right, so you figured they were really, really accurate.
Right, and which was why I was surprised when it missed one of them. So to answer the other part of your question, I did use waypoints. So, you know, I had a list of waypoints that kind of circumnavigated some of the rough spots and took it on a somewhat circular course to give it the smoothest course that I could.
I saw that. I went back and watched all the videos from last year just to get a feeling for what was happening. Ray,
Yeah.
which
Yes.
GPS waypoints did you use?
I don't know that I actually did go back to the original ones. I had basically a little handheld unit that I made and tried those, but I was on the way to the second cone. I got stuck in the weeds and was kind of surprised that it was that far off. And I don't remember though switching back to the ones that Doug provided. Or
Those of you who have used RTK waypoints, just out of curiosity, have you done anything to validate the understanding you have about the accuracy of your RTK points?
So I was the only one that had RTK last year.
I didn't that time.
And I have not done anything to try and validate the accuracy.
Okay. When you talk about the fact that you were surprised that you had missed some apparent waypoints, whether you think that's because of simply the navigational following logic you're using, or because you have issues with the GPS measurements or the RTK measurements.
So I found something. I got a new learning at last year. When I initially tried to run, the RTK antenna was sitting up on a post, and it would cause the front bulkhead of the electronics compartment to flex and disconnect power from the robot. So, my first couple of run or two were a bust because it would run for 10 meters and then quit. And so
it wasn't using high-end duct tape at the time. It was some gray, I think cheaper brand.
It tuned over the robot from the post that the antenna was mounted on. And
there were two others who had robots. Mike?
Yes, Scott.
Well, let me just finish because
so Scott's not here.
I want to make an important point.
Okay, I'll go ahead.
I think that the electronics in those RTK antennas is so sensitive because it's trying to pick up a fraction of a wavelength as it comes in, that I believe it was being affected adversely by being
jerked around basically
by the motors and the electronics. And so and you can tell that I could tell that was happening because it would change from RTK fixed to RTK float, back to fixed, back to float. So it was losing RTK fixed, which means it lost its lock on all of the incoming phases being exactly aligned. So I think that kind of I don't know that regular GPS is that sensitive to electronic fields coming out of my computers and the motors and such, but I discovered that RTK is. So anyone who's using it should take care to mount it far away from electrical interference.
Did Doug or any of your others, did you hear any other comments from Scott or the fourth person? I've forgotten his name. I'm sorry.
Raj.
On GPS, with regards to GPS waypoints?
Raj his robot wasn't very successful.
I saw that.
Scott he had no problem. He drove, the cones. He went to each cone. Okay. He did have a problem getting his last point, but it was algorithmic. He got somewhere where he didn't see the cone in his initial approach, and he got behind it somehow, and then all of the wiggles and stuff that he tried to do to find the cone didn't work, and then after a while it cut off, I believe.
Okay.
If I remember right, that was a year ago. So, but if you can look at the tape.
Yep.
Okay.
Yeah.
Yeah. And Actually, I'm pretty certain I had some programming errors. I had put in 7 different waypoints, but the code was only going to access the first 3. I forgot to make all the changes I need to make in the code. I had the magnetic declination off by like 10 degrees for some reason. I don't know why. I convinced myself it was like, positive 2.56, and it's actually like negative 7.6 or something. What else? Oh, I broke the golden rule. Don't try to change your code the day of the contest. So anyway, there were plenty of things to make it not work right. So
Wait, did you say the rule is don't change it or start it and finish it on the day of the contest?
oh, starting to finish it. Boy, that's even more challenging.
I keep getting that rule mixed up.
Yeah.
Now, Doug, you had asked about which of my samples was which. My live map is still running here in my browser. Shall I switch to it? I'll show you which is which. I don't have any other questions at this point.
Yeah.
All right, let me close the window. And then I'll see
But the
if I
point
can.
of it is, Tom, whatever points everybody's allowed to go get their own. But
Yeah.
the contest, the person running the contest, which sounds like it's going to be you, you have to supply a set of accurate, as best as you know.
hence my appreciation of the term accurate.
So, like I say, we tend to use a GNS, and we usually go back to each waypoint twice. Okay, and just make sure they're close. Okay.
Okay.
Now, how many digits do you collect? You said you're off. You see a variation in the last digit. How many decimals do you collect?
Whatever.
Probably just
I
5.
can't remember. I think it's 4 or 5.
Yeah. I think GPS RTK, you really can go out to 7 decimal places.
Yeah.
So
Yeah.
I'm collecting 5 digits after the decimal point in
Yeah.
each of these in metric.
And like I say, you try to make an honest effort. That's what you can, because like I say, we could argue the centimeter down for forever.
Yeah.
yeah.
And the point of it is,
Single digit meters. But
Yeah,
Pat
so
Crone, any thoughts?
I am getting typically 5, very rarely 6. I connect anywhere to 10 to 11 channels on my GPS. I'm using a little U-Blocks M8 or whatever it is. I did do a track last year where I walked through the park behind my house. I did sort of a perimeter walk. And I was actually very impressed at, when I plotted it on Google Maps using the KLM data conversion tool, how, relatively accurate it was. 5 decimal points, I believe, is 30 feet. 10 meters or 30 feet accuracy on a GPS. So your waypoints that you collected, I think, come very close to that.
Yeah. And I think another thing too, that, all these people what do they call it? Where people hide little treasures in the woods and people go
Geo-trackers
geo-tracking.
or caching.
Yeah, I've done geo-tracking, and it's amazing. You can almost always find the geo load or whatever they call it.
Yeah.
I mean, even though it's hidden, but I mean, your GPS will get you close enough to find it.
One of those hiking GPSs I have was intended exactly for that purpose. It's a geocaching hiking GPS.
Yeah.
So that's a lot of extras for that purpose.
Yeah, and they're like I say, I've got a newish Garmin, which is really good. But an E-Trax, God, those suckers I think they were put out, and I mean, I don't know when you got yours, but I know they've been around a while.
80s maybe.
So, I mean, they're GPSs, I believe. That's how long they've been around. So I mean, you can even go to Google. I'd be interested to take your map and go to put it on Google Maps, and then do a pin and see what it says it is.
Yeah. Yeah, I agree. I want to add the Google Map points and see how they compare. But like I said, I don't know of any reason why I should believe them any better than a GPS. I have not seen anything that says they're that accurate. So we'll see.
How often does your car run off the road on the GPS? You know what I mean?
Yeah.
Not very often anymore. I used to. I don't remember when they did.
Well, I usually don't let my car be automatically navigated by my GPS. I usually
No, but what I meant was if you watch the dot, you know, it stays on the road.
only when the map has the road in the wrong place.
Yeah. So
You asked the question about which is which.
Yeah, I don't know if you guys remember, but some of the first ones, you know, it had a real hard time, like if there were multiple lanes together, like service road for a highway and the highway itself, it may bounce back and forth between the two because it really couldn't tell you where it was.
Yeah.
Yeah, my car's GPS sometimes has it on the wrong road that's parallel and is telling me to get back on the highway.
Yeah.
Like that.
but I do think that website you're showing there, visual GPS visualizer, let's put that link in the chat, because that looks like it might be a nice little thing.
Yeah, I found it to be a very nice tool and easy to learn, although it has a lot of capability. The red dot that I'm pointing to right now, that's an iPhone. Anything that begins with ROZ is my iPhone.
I can't find your.
Oh, yeah.
Can you see it?
Where's your
ROZ something.
You've got that little real flag.
ROZ2.
Yeah, it's where the mouse pointer is.
I can't find the mouse pointer.
See it move?
Oh, there it is.
Yes.
Yeah.
See a little white flag pop up?
Oh, okay. I saw.
White flag?
Yeah.
That white flag is an iPhone.
Okay.
The one just to its left of it is a Magellan GPS.
Yeah.
The one above it is a Garmin GPS.
Okay.
Over on the left side, that one's a Garmin. That one's a Magellan. That's my Android, and that's the iPhone on the bottom.
Mm-hmm.
Okay. And down here, that's the Garmin. That's the Magellan, and that's the iPhone. I don't know that you can draw any conclusions from that about which is accurate or not accurate. Other than my Android, which I am very unhappy with. That's an Android. And down here, that's an Android.
So I just did the calculation, and I think that a change in the fourth decimal point is a 10 meters. Fifth decimal point is 1 meter.
Okay. Yeah, that sounds right.
Yeah.
All right, wait a minute.
But you're talking about the accuracy, and you're talking about resolution as if it's the same
Yeah, I
thing
think
as accuracy.
resolution. I think he was
Yeah.
talking about.
Yeah. So I was asking Doug how many decimal points he looked for, and he wasn't sure if it was 4 or 5. I think it would. I hope
Well, I think that was whatever the last one is. So I think we'd let the last one be different. Okay. You know, maybe 1 or 2.
But it matters whether it's 4 or 5, because that affects whether it's different by 10 meters or 1 meter.
Yeah, that's what I'm saying, is we wouldn't do the 10 meter one. We'd do the 1 meter one.
Okay. Good.
Yeah, but if your GPS reading is bouncing around, your fifth digit is bouncing around, it might as well be useless.
Well,
Standing still.
depending upon how big the bounce is.
Yeah.
Yeah, well, even if it's shifting by 1.
Well, shifting in the fifth digit by 1 is
No,
1 meter.
It's
If
1
I-
meter off. That's like I say, that's inside of 10 meters. So that's, as far as we're concerned, that's a good point.
Well,
So-
if I have time, I'll collect a little bit more data and see if I can learn anything new.
Mhm.
I don't know if I will or not. We'll see.
Yeah.
It just struck me as I'm putting a lot of weight on GPS waypoint navigation, path following.
Yeah, what I'd like
This
to
will not
see,
work well.
yeah, what I'd like to see is, okay, you had some given waypoint that you thought you were at, right? So you have a waypoint number. Yeah, what I would like to see is you to map all of these things, I think, onto Google Map. So see how they spread on Google Map, and then have Google Map give you that exact location. Because
Or maybe a center point of all the points that.
yeah, but the way you would have to do it is you'd probably have to take one of the points, and I would use the iPhone 11, and I'd say, okay, this is truth, okay, because it's, I think, the best of your measurements, and then plot how far away they are from that, and see if there's what you can pull out of it. You probably can pull out some variance. If you wanted to do it, you could do an ANOVA on it and get some variance out of it. Find out how much of it's attractable to the actual unit. But anyway, I'm sure you'll manage it, Tom.
It's an interesting experiment if I have time.
Yeah, it's a lot of fun.
I still have a lot of work to do on the software for my robot. So
Or you could say for a small amount of money, you could give the other contestants more accurate GPS information.
what I may say is, here are the GPS coordinates measured by my robot.
That's right. Yeah.
Well, you shouldn't do that. You're not supposed to run on the course with your robot before the event. That's why we don't release coordinates until the day of the event. You're not supposed to go on it, and you should try to stay off, because you got to have a level playing field for Pat, because Pat's not going to be able. I don't know. Are you going to be there over just for the contest, Pat?
Yeah, I am showing up. I'll be there arriving Friday evening, showing up on site Saturday morning.
Okay, so at least you'll be able to run on some of it beforehand, just to make sure that you don't have something like, oh my God, I didn't know I was going to go through 18 feet of Kentucky bluegrass or whatever. So
I already paid off the guy to mow the grass the day before and to rake it.
okay,
Run the roller over it too. Eh?
yeah.
I'm just looking at the
Okay.
size of your wheels in your picture. How big are those wheels? They're pretty big, aren't they?
Which one you talking about? The big
Oh.
one? This one?
Oh, not that one. You're not running that one.
No, I'm
Show
running
me
this
what size are your wheels?
5 inches.
Okay, mine are 5.5.
Oh, see, I'm already at a disadvantage.
Oh no.
Oh no.
I go wheel envy.
Yeah. Hey, we could send you some what do they call those, horse apples?
Yeah, I think you
You
should
could
send a
scatter them
box.
around the.
You could just load up your robot with horse apples and kind of drop them behind you as
That's
you
right.
go.
The closest we can come to that here is goose droppings.
Oh yeah, way
Kind of
messier.
begins.
Goose drop.
Okay,
That doesn't
I think
sound
we're
good.
wandering off in the weeds here. So
Yeah.
let's move on to Pat.
Okay, I have a couple things. So if you want to pin my camera, I will see if I can get this guy close enough into the scene.
Ooh, good looking
Damn, that
robot.
thing is a
Pat.
monster.
Still got wires hanging out. It's not done yet.
I have a longer wheelbase too.
So
Wow.
this is basically this week's work, trying to move everything over.
Oh, yay.
So I've got my
Wheel.
motors running.
Gold star, wheels are turning.
I've got my PID loop was working. I've got motors turning. Everything was going backwards and wrong speed and wrong PID. And the good thing with backups on your Raspberry Pi and software is that I was able to find everything back in 2021, the last time I ran this chassis.
Carl, I don't think this classifies as the wood monster anymore.
That is not, that's outdoor bot.
Oh, I'm mixed up.
That's
Yeah, the
Oh.
wood monster is made out of wood.
I had
It's
to
behind
switch
him, isn't
from the Bob, the big outdoor
Hey,
bot
Joe.
to my regular outdoor bot because I don't have enough time to troubleshoot the mechanical system on it.
Okay.
I had to get wheels spinning and everything moving, and I didn't want to throw in the mechanical stuff on top of it. So I
All right.
switched that to my other frame.
I've corrected the
Yeah,
notes.
can you stand her up on the robot so we can drool on it? Yeah, it looks good.
So there's the robot.
Okay.
And it's just sort of hanging in place. I'm running off a 10 amp power supply right now, 12 volts. So I have my little
Oh, the
010 sensors to go onto the front. I've got at the back a little Arduino Uno for motor driver. I've got a Raspberry Pi in there for brain. I've got a little Nano sitting in there. Where is it? Right there. A Nano sitting in there for other sensors. An SSD. It's 4-wheel drive. I have some feedback, and I don't know if you can see the LEDs.
Mm-hmm.
So right now, I'm getting compass feedback. So the blue LED is always pointing north right now, just for
Oh,
testing.
Nice.
I like that.
Nice
Yep.
touch.
The orange one is supposedly the target direction that I'm going, and it'll be probably green. And if it turns orange, it's spotted the cone, and that's its new target.
Like it. Sounds
Yeah.
great.
There is the compass sitting at the top. That's an LSM 303, I believe.
Mhm.
And that's about it for that.
Nice.
And you can unpin my window. I'm going to share my screen. Okay, so basically that was the readings I'm getting back. I was sending 30 centimeters per second. I'm getting back 30 centimeters per second. My output power was 76 out of 400. So the max I can put out is 400 to the motors.
Mhm.
And that's just how Polulu does it in their library. So it's essentially 256. So that's my right motor. That's my left motor. That's how many encoder ticks I got back in my sample period of 50 milliseconds. That's both motors. This is the speed that I was sending, 30. And that's my actual encoder counts coming back left and right.
Cool.
So I've got that working and I'm pretty satisfied with it. I have a test program that's running just to send the data, just send the speed. So the other one I was working on in this top window, if you can see that, is I basically put in some GPS coordinates and just doing some calculations. And I come out that I'm 41.44 meters away is my target at a bearing of minus 26.65 degrees. That came from this guy. So there's my into a little park behind the house. Homeless guy here is no longer there. He had a camper. He's gone. So anyways, I just basically pulled up the GPS coordinates from here. And the same thing at this guy. Entered those into my calculations, and what it gave me before I do that. So I calculated it out, and then I convert it to an XY coordinate in centimeters, basically.
Sounds
So-
good.
So I'm minus 1859 centimeters X, and Y I'm plus 3704. When I plot that, basically there's what I've got. So north, I'm assuming is here. And if I go 3,700 centimeters in the northern direction and minus 1859, or I end up with my target, which looks similar to what I got on Google. Essentially, there's where I got. The angle looks the same. I'm assuming it is the same for now.
Pat, you can get the distance. Yeah, there it is right there. It's supposed to be 41.27 meters.
Yeah, so they've got 41.27 meters.
And what did you get?
And I have 41.44.
Okay,
And
that's
then
pretty
when
good.
I pasted in their measurements, I got a lot more digits.
Mhm.
On the screen when I look, I think I got 5 or 6 digits. Minus 81. But I was just approximate. I'm close enough. We're talking about less than a meter here.
Mhm.
I'm not worried about that. If I can get that close to a cone, I'll be amazed.
Yeah. So you're using 0 to 180 to 0 to minus 180 coordinate systems on the angles. I
I
assume.
will be. I'm not right now because
Well, you got
Google-
minus.
this gives me minus on this side
Yeah.
and this gives me plus on this side.
Right.
And I will be converting everything. My compass is 0 to 360 right now.
Mhm.
And I will be converting that to plus or minus 180.
Gotcha.
Is to help work out with the math. So my question was, so if I travel, I'm assuming this is the X direction. If my X point is negative, minus 1859,
Right.
well, I'm at minus 1859 here.
Yep.
So X positive is in this direction.
Yeah.
So if I travel straight from 0, 0, to be going to the right in this direction, I would have to be going east, correct?
If
Yeah.
you're going to the right, yes, but
Okay.
you're,
This is
in this case, you're going to the west side, right?
Yeah, you have to be careful here. It depends on whether, okay, if you're using the navigational where it goes from 0 to 180 to 0 to minus 180.
Yep.
Okay, so, what you just said is right. So the positive x-axis is to the right and its y-axis is north. If you're using x-axis as your direction when you started, then you can see that you'll be flipped 90 and y will actually end up, it's not going to be equivalent to your compass. So you have to be a little careful just to make sure. And this is also, I would highly recommend that this is a thing to really do a bunch of testing, like a lot of different angles, a lot of different points, and see if they all make sense. They always, when you flip over from 180 to negative 179, does it do what you think it's going to do, or is it going to be pointed in the wrong direction? So
Yeah, that's
you
my
gotta make
point.
sure there's a lot of testing.
That's my point with here. So I'm going to leave from my backyard, drive out to a point, and head up there. So to see if I can, follow a waypoint, and know that I'm actually,
Yeah, Yeah, but I'm saying you can test this without, by just putting up a lot of use cases without actually running your robot, since you're going through a bunch of calculations, right?
Yep.
And you just see if the calculations always work. And that they don't, like I say, when you do things strange, does it still come out with the right strange answer and not something that's flipped? I'm just saying, just test a lot, because I have had a situation where I thought I had it nailed down, and when I put the robot down in a specific situation, it started turning and it just went wrong direction, and I couldn't figure out what was going on, and it was one of these calculations wasn't right.
Yeah, and that's why I brought up that graph, because the off by 90 degrees sort of bugs me.
Yeah.
So
Yeah.
if I think I'm going straight ahead and I'm going in the X direction.
If you follow Dave Anderson's conventions, which he got from, he was a geologist, I believe, is so what the direction you start off and your robot starts in, it's pointed in Y. Okay.
Okay.
And
I would have assumed it was pointed in X, and that's where.
And that's the way Ross does it, and that's the way a lot of roboticists do it. So,
But I did follow, for the most part, I believe I followed David Anderson's.
well, yeah, because I mean, you got to, yeah, you got your compass. I believe your compass assumes that the north is Y, if I remember right. I'm pretty sure that's the assumption that's made, that Y is north.
Okay.
Okay. So, you know where you have two equations. If you're doing differential, there's two equations where you calculate the X and the Y in the navigation or the odometry. And one of them is something cosine and the other one is something sine.
Yep.
Okay. You can do, if you're wrong, you can transform those. And it is equivalent to flipping axes. So, anyway, just try to be consistent, I guess is what I'm getting at. Yeah. So if you look at that, you can end up with things like otherwise, if you flip sine and cosine here and
Yep.
you start tracking, you'll see it's flipped one of the axes.
Okay.
Okay, I'm just saying. So I'm just saying, just check this part out. It looks trivial, just two little lines of code there.
Yeah.
And you shouldn't have to change that, but you need to make sure that all of the conversion routines you're using, the ones that are taking the GPS and saying in the world, this puts you right here, and all of those, you got to make sure they're all talking the same axes. That's all I'm really.
Exactly. And the other one I'm having trouble with is the radians and the degrees. So.
Huh?
Radians and degrees.
Yeah.
So radians and converted to degrees and got to be converted to plus and minus 180 to.
Yeah, and that exactly, all of those can go wrong.
Yep.
Yeah. And but the nice thing is that if you go out on the internet, or I'm sure you could probably ask one of the AI bots, they'll give you the routines. There's a lot of pretty classic routines.
David Anderson has several papers on it.
Yeah.
And they're very handy.
Yeah.
So the other one I had to present today.
The A010, huh?
Where'd it go? The A010, which died on me.
It died on you?
It died on me.
I ran mine for like Weeks.
Just my
The GUI
the GUI died.
makes sense.
Makes
Huh.
sense. Yeah. Make vision is not.
Oh,
Do you have one open already? Maybe.
No, I had. Yeah, I had one open, ready to go, and they're both hung up. So that's sort of builds that.
Bizarre. There you go.
What is that? What's that? Camera. Yeah.
There you go.
Big, a very big model. But I don't know if you can see the picture in the corner. I don't think I can make it any bigger.
Yep. Oh, actually, you can. You can just put your mouse on it and pull it in 2 directions. Give it a try. There you go. Oh, okay. Made the box bigger anyway. There you go.
Yeah.
Ah. So you're
I
getting
know.
that.
Is that a little better?
Yep.
So
Yep.
we are
You can see
seeing
it just fine.
one cone. If I move it a little bit, we pick up the second cone. Those are about 6 inches tall. And about the closer one is about 7 feet away. The farther one is about 12 feet away.
Yep.
So I am picking them both up.
Yep.
There's some interesting stuff that happens. Every once in a while, I'll get a flash, a traffic cone that picks up a shadow there as a traffic cone. Then I don't know if you see that pop up once in a while. The left.
Yeah, I thought it was kind of weird with yellow 5. It's like the confidence is around, somewhere between 5 and 6. So it's 50 to
it's the highest
60%
I've gotten
confident.
is 60% confidence.
Yeah. But it seems like if I improve the model a little bit, the confidence went up just a little bit, like from maybe, mid to high 5s up into like, low 6s.
Yeah.
So, but, okay, that's saying, 50% says it thinks it's a cone, but it may not be a cone. So
It's exactly. So at 50%, but overall, I don't think there's going to be a lot of confusion out on the course.
Yep.
My biggest worry is the fall colors. It's I can spot it if I get within close enough with the GPS coordinates that I can start doing a scan for a cone and see what I can find. So that's
you're using bigger cones though, right?
I have my cones are a little bigger than yours. You guys are using, is it 18-inch?
Think so, yeah.
Yep.
Tom, you have 18-inch?
12.
12-inch. So I have some 27-inch cones. I happen to have 3. I'm going to bring them anyway because I'll just throw them in the truck and bring them.
Bring them over. Yeah.
I'd rather go with a bigger cone than a smaller one.
Yep.
You mean you don't have metric cones in Canada?
I bought them on Amazon, so nothing. Well, the only thing metric on Amazon is hardware, screws.
Yeah.
Gee, do they make metric cones in China?
Yeah, I'm sure they do.
So that's been my work this week, is basically to try to get that guy going. So I've got the program running in Python. I'm just working on adding a serial routine so I can spit out X, Y, and basically
Oh, the centroid, yeah.
X, Y, centroid, and look at the height and the width. So if I get something weird that, it's wider than it is high or something.
That's
then,
impressive. That's impressive. Which camera are you using?
That is a mixed cam, MAIX cam.
Oh yeah. Okay.
And it's, I used a subset of Doug Parody's pictures. So I removed a lot of cones. Incidentally, all of the cones with the stripes on them, I've removed from Doug's data set, and I'm still spotting the cones with the stripe on them.
Yeah.
Maybe that's why your confidence is so low.
It doesn't seem like it gets much better than that.
It wasn't any better when I had the striped cones in there.
Yeah.
I
That's
think
my experience anyway.
Yeah. When Pat's done, I got something I was gonna say. I did do some work in this area, so maybe I might talk about it.
So that's it. I'm done. I just wanted to show my progress on my code tracking.
Yeah,
and that's
Very impressive.
that's great. That's really great, Pat. I think that when you set the acceptance level in your program, set it down, like if you're only getting 50%, set it down to like 30%, because it's not like you're going to have a lot of near cones. I think you'll find that you might pick up one that, say, one of these things drops out at I don't know, what's your confidence level now set at? 50, right? Yeah.
It's at 50,
right now.
I think roughly on both of them.
Yeah. So what if you take it and set that to 45? I want to see if it becomes less blinky. Just set it.
I don't know if I can set it here.
Just set it to 45.
Yeah, I don't even know where to set that.
Right there where it says confidence threshold.
Oh, confidence threshold is 5. Okay. So you want to set it at 45?
Yes, put a 4 there. Yeah, 4, 5.
Okay.
Okay.
And what's IOU threshold?
I'm trying to think. I'm not sure what that is. Just leave it and let's see if it does any. Because when you had that back cone dropping out occasionally.
Yeah.
Let's see if this helps it any. Let's see if you're just getting a couple of near misses. Can you stop it and restart?
Yeah, I did. I'm going to drop it again. I'm going to drop that to 35.
Okay. Yeah, and if you got something that looks like a cone that's not being flagged, this will also help you find those objects that, you'll find out whether or not it's something you want to do.
Start it.
Yeah, I see some 40s jumping in there.
Yep.
Yeah.
So probably that 0.5 should have been lowered a little bit.
Yeah, I'm at 0.35 now.
Yeah.
Wow.
So I guess I'd look around to see if there's anything. You got like an orange toy or anything? Oh, there you go.
Yeah, you see I'm picking up the shadow as a
See where that's coming in. For some reason that's okay. So it's seeing that shadow as a cone.
Yeah.
And it's picking it up at, looks like, so I think 40 or 45 might be the kind of you might find that to be, what I'm saying, you can tune this probably a little bit. I guess that's what I'm saying.
Okay, yeah. Well, I was just amazed I was detecting a cone.
Can you rotate the camera a little bit?
You're still picking it up once in a
I'm
while.
still picking up that shadow.
Yeah. Be interesting. That might, I don't
Is
know.
that reflecting like a little bit of the orange on the wall, or is it just the shape of the
I think it's the shape.
shadow of the cone?
I think it's picking up the shape.
I think it's in a triangular shape.
Okay, yeah. Huh.
Anyway,
Can you
I don't know.
rotate it? Not side to side, but
Twisting.
Twisting,
yeah. So it's not vertical.
so it's not vertical. So
yeah, it's obviously picking up stuff now. That's
Yeah, it's probably more on color. Yeah.
I'm getting 60% in there. I can see flashing by.
yeah.
So
I don't know. Maybe that's why 50 was in there. You just have to see what works best.
Yeah, I never tried to figure out what the actual frame rate was. You know, it may have a lot that, you know, if you set the threshold to 50, you know, who knows what rate it's actually,
yeah,
you know, giving you.
This seems like an opportunity for a leaky bucket algorithm to try and establish over a longer period of time which ones are
Yeah.
more reliably have a higher value.
Yeah, that's what is the name? It's not a leaky bucket. That's a good. I think they call it a leaky capacitor.
Leaky
No,
integrator.
leaky integrator. Yeah. Yeah, that's a good point, Pat. So what it would do, what that is if you get a cone detection at a certain XY location.
Yeah.
Okay, you get 1. It doesn't fill your bucket, just gives you 1. So now if you have 5 in a row, your bucket gets filled and you'd call it real. But if you get 2 and then you get a third one and it doesn't, then you start back over again. It's a 1.
empty the bucket and start over.
Yeah, or you can yeah, usually that's the way they do it. Sometimes they just subtract 1.
Or subtract 2, so it will leak out faster than it.
Yeah.
Then there's different tunings you can do on those leaky buckets.
Yeah. And it's very, very useful algorithm. That was the first thing that Dave Anderson taught me when I was knee high to a whippersnapper. You know, that was the first thing he shared with me to help me with my code.
Okay.
I was back in the days when you were sneaking out to Rocky Horror Picture Show.
Probably.
What do you mean? That was 3 days before they invented dirt.
I
thought it was last Friday.
You both had hair.
Yeah, exactly. I know about that hair thing.
So it wasn't last Friday. Okay.
So anyway.
So that's my experimentation this week. So I'm making progress. Still got a long way to go. I was on the phone with my boss today, and he says, "So we got all this work to do," and he says, "Don't talk to me till after the 26th."
I bet that went over big.
Oh, it's no big deal. I'm part-time for him. He knows I'm working robotics.
Yeah.
So I'm working on proposals for 2025 for him.
Mm-hmm.
Incidentally, he wanted to throw a bunch of cash at me. How about I sponsor your robot?
Yeah.
And I said no.
Tell him, yeah, you just bought a Spot from Boston Dynamics, you know.
Exactly.
Did he cover the cost for that?
Well,
Cool, Pat.
that's it for me,
Good
guys.
job.
Thank you.
I think Carl was up next, and then we'll be at open mic.
All right, cool. So the sum total of my robot things for this week, I've just done while I'm listening off to the side. It looks like I may have prepared the code for Robo Columbus this year back in December of 2022, after the last time I tried to do it and it didn't work. So maybe there's a shot. I'll have to see if I can still figure out how to turn it on That'll be exciting. But the issue was at the time I had the OpenMV cam used a serial transfer down to the Mega driving this RC chassis, and it worked just fine, except every now and then it would drop a bit. And wouldn't you know, it happened to drop the bit that says, "Oh yeah, I found the cone. Time to back up, turn around, and go the other way." So at the contest, 3 times in a row, it made it within 10 feet of the circle around the cone. And then it said, "Oh, I found the cone," and backed up, and it went. It's like, no. So I apparently after that, I went home and I was so ticked off that I updated my super crude protocol to be a little less crude or more crude, depending on how you. So basically, I just throw more bytes across the interface, and they all have to match, or it just throws the data away till it gets good bits. So that's the hardening that I did. But I can't remember if I got this working or not, or if I just coded it. So I have to go sit it out and run it. But anyhow, what I intended to talk about was non-robot-y things. And for non-robot-y things, this might apply more to those in Dallas or people that just like it. But this is a steampunk technology kind of update. I think I've mentioned it before, but basically, I think maybe the last working copy of this 1.2 million pound steam locomotive is going to visit Fort Worth this Thursday and Friday, in theory. Can you guys still hear me? My screen share.
Yeah, I heard it.
Yeah.
I saw that. I got some friends that are into trains, and they've been advertising it's coming through. That's a massive thing, man.
Yeah, I was going to share my screen a little bit, but it looks like my mouse has died and everything has died, but my voice is working. Okay.
Your video is still good.
I have a couple more. Oh, here we go. Here we go. But so
Animagraphs did a great animation of how the big boy locomotives work. Check it out on YouTube.
What is it?
Animagraphs.
Animagraphs. Maybe if you find it, you could put the link in there.
Yeah, sure.
But the size is not so clear from here, but they show a human, and the human, and these wheels are 6 feet tall. And, just by scale, there's a sedan, there's a school bus, there's a diesel, a locomotive, and there's the little big boy, and then there's a Boeing 747.
Wow.
I mean, look at that. And they talk about evaporating surfaces. The tube's 967 square feet of evaporating surface. I mean, 6,000 square feet of evaporators to work with the steam. So
Yeah, I like the tractive power. It's like 130 some odd
95,000
pounds.
Yeah, that's hard to fathom, but I guess it was made to pull large loads over the Rockies in the West. So anyhow, so that there's that. Then this is the schedule. They say that parking is going to be kind of crazy. I hear that the convention center might be a good place to go, but be prepared to walk if you choose to go to Fort Worth on the 10th or the 11th. I'm planning to go kind of earlyish. And then I have 2 more links on one of those days. I don't know which one yet. And then I have 2 more links to share. Thanks for that link, Karima. That sounds fun. This first link is, so it turns out the guy rebuilding the engine of my car is into this stuff too. So he took a video 2 or 3 years ago when it was last here, and they gave a technical talk. So if you want to learn about it ahead of time, this is what we might see if we go Friday. And then this is just some other thing that reminded me about it. I put the link in there for this. So anyhow,
Cool.
if you're into that kind of thing, 1.2 million pounds, if I remember right. it doesn't run on coal anymore. A few years back, they converted it to run on like gas or
Oil.
oil. Yeah.
Yeah.
But it's a working steam locomotive. Yikesies.
Yikes. Interesting. Well, thank you, Carl. Let's throw it open for open mic.
Okay, Paul, I got something I wanted to show.
Yeah, go ahead, Doug.
Okay.
Next time we might want to be a bit more hospitable to newcomers and let them like.
Yeah,
go
that's
first.
a good point.
Yeah.
Right now, is she?
I didn't realize. No, she just left.
Bailed. I
We
threw her
ran
away.
her off. Yeah.
I scared her off.
Anyway,
She had been to a couple of the Saturday meetings, I think.
Oh, really?
I've seen her there before.
Oh, okay. Well, we're just a reminder we're recording at the moment. So, Doug, you were about to share something.
yeah, okay. So I did something that was more of an exercise to try and use some different models. So this is my data set trained on RoboFlow using Colab GPSs to YOLO 11S. And it was a little disappointing. Its precision was 90%, and its recall was roughly 86 or 87%. And if you look, I'm going to have to go to the actual page. So I'm going to lose what I'm seeing. Let's see here. So if you, you see here, you see this 3-cone picture. Are you seeing that? No.
Yep.
Yeah, you're seeing it. And you can see that the front 2 cones are picked up and the back cone isn't picked up.
Mm-hmm.
All right. And so this is a test image. It's just an image I got off the internet. And you can drop them in and put it in here. Now, if I go back to my previous example, it's very similar precision, and you can see here it's using the COCO-N checkpoint. So this is not a YOLO model. And if I put that same file in, if it'll let me do it. Here it is. And let it calculate. Come on. Here you can see it picks them all up. Now you also see that the confidence level on the front one is lower. I don't know how to read that, but if you were at 0.5, it would capture all 3 of the cones here. So this is the one that I was planning to use, but I wanted to try some of the YOLO models. And so there is a tech. If you have a robot flow, I think you can copy my database into your RoboFlow, your own, user, whatever you are. And so Pat, in your case, you could put whatever you're using, and you could train it using YOLO 5 is also available. I'm trying to think of where. I
used your images and your XML data when I did my training, and I trained it on Max Hub.
Yeah, I know. And I guess the question I have is, what models are available on Max Hub? Do you know?
For that camera, I think it's only YOLO V5.
Yeah, version 5, I think, is it.
Okay.
I haven't found any others anyway.
Okay. All right. I guess what I said is Okay, I've decided to use the Pi Insight this year, which is essentially Oak D Lite without the depth camera. So I just thought that anyway, I'm working my way where I'm learning how to customize the models is what I'm getting at, and I'm finding that RoboFlow is a good technique. Be interesting to know what type of input the Max Cam takes. I mean, do you know?
I want to say it's a 240 by 240 pixel image. I think that's it.
Okay.
As far as what you can actually take with the camera on the unit.
Okay. Yeah. Because I want to say Yellow 5 generally uses 640 by 640 images.
Hmm.
So, all right. Anyway, I guess what I wanted to say was I was playing around. I went from, this is pretty much the standard RoboFlow fast model. They use Coco N. And when I went ahead and used Yellow 11 small, it did work. I did get it in there. It was almost equivalent. So interesting. I just thought I'd share that. Probably not that interesting, but I thought it was interesting.
Yeah, I lost you. Sorry.
Yeah. How do I get out of this?
So RoboFlow, does that work with any other cameras?
It works with a lot of different cameras, yes. But a lot of cameras use Open Vino, like wine, VINO. And how do I get out of the? It's not telling me how to unshare. Okay, I'll do it that way. So anyway, it does use. So a lot of cameras use that, and that's what I was wondering if the Max Cam used that format. If it did, it would be real easy to move different models besides the 5. It'd be interesting to see how they handle the weights, because you could obviously get the weights for the different models from RoboFlow. Okay, so it'd be interesting. I don't know. It's a little confusing to how to do it, but I did find out that with Colab, they'll allow you to use their GPSs. They'll spin them up for you. And there's Jupyter books in RoboFlow Jupyter notebooks that you can use to kind of like step through the process. It's kind of neat. So I just, as you get into this, you might want to, Max Hubs looks very similar to RoboFlow. So maybe that's the way to go for that specific camera. So see, I've got one Max Cam, so I'm going to have to try it out, but not this year. So
it's what I've got, and it's I think slightly better than orange blob detection.
oh yeah, I definitely think it's the right way to go. Yeah. Yeah. I wouldn't, you know how Harold said he was a suspenders and belt type of person. It might not even hurt to throw a blob camera on there too, if you had one.
Yeah, well, there's room on the Max Cam to install other libraries.
Yeah.
But I sort of doubt that I'd be able to install OpenCV and do blob detection on the image.
Mm-hmm. Mm-hmm. Well, you could, yeah. Okay. Yeah. Well, anyway, so have you got yours to work, Ray? You got a max cam too, don't you? I think
Ray's frozen.
Ray is frozen.
Ray looks frozen.
Yeah.
Or is he intently staring at the screen?
Deep concentration.
Yeah. Anyway, okay. Open mic. Go. Yeah. Anybody else got anything?
Well, I got a new toy today. It's apparently it was like an Amazon deal. I
Ooh.
guess they got like Amazon big deals going on at the moment. And I saw Kareem's little monitor that he had for his Pioneer robot, and I've been lusting after one of them for a while, and anyway, it's a 15-inch monitor. It's got a couple of USB ports and mini DVD, a mini HDMI, and anyway, it was like $80, 70 bucks. I was
Whoa.
like, wow, that's like super cheap.
Mhm.
Anyway, that was my exciting purchase today. So I
Cool.
now have a spare monitor that I hook up to the RPi when I break it and it doesn't boot.
Yep. I've got something similar that was meant to be a fold-out screen on a laptop. And so you stick these magnets to the back of your laptop, and it literally folds out so you have two screens. But my laptop's so old that it doesn't spread the screen between two screens. It just mirrors it. So I'd have two pictures of the same thing. So I use it as a skinny monitor for stuff.
Yeah. So Carl, are you going to try and bring your robot to Robo Columbus? If you can get it working, you're muted.
Yeah, if I can get it working, I'll bring it. My next
Cool.
trip is looking like it'll be right after the next Saturday meeting. So if I can get my stuff done, I have a lot to get done before then, and this is part of it. Because after the trip, then I don't want to get back. Then it's off to Chicago 4 days later for the granddaughter's birthday, and then after that, it's Robo Columbus time. So either I get it working in the next 2 weeks or not.
Good luck. Okay, who else has got something? Ray, you're muted.
I said, sorry, my internet connection was getting flaky here for some reason. Yeah, I think Kareem had said that it supports several different, I lost that part too. Anyway, several different, I guess, I don't know what you call them, whatever you classify as YOLO 5 and YOLO 8 and all the others. But I think right now the only one that you can use is YOLO 5. So it may support those others, but how do you, I don't think there's any examples on how to use them. So, and there was, as far as I know, the only option that you can choose on Max Hub is YOLO 5 now. So maybe it'll be supported in the future, but
Marketing lies.
Yeah. Anyway.
Okay. Are we running out of steam? It's
Even Big Boy runs that.
we've been going 3 hours almost. We covered a lot of ground today, and we are doing some seriously intense tech in this group. It's pretty inspiring to see what everybody's doing, and I hope it all doesn't collapse in a steaming pile of something
Contest day, you mean?
on the contest day, but
We-
we shall see. We venture bravely onward.
So I've
All
confirmed
right.
both of my hiking GPSs are GPSs. Both of the cell phones are GNSS. And my poor old robot GPS is just GPS. Although it can read augmentation system signals if they're out there.
Well, one of the comments I was going to make, Pat, Tom, was you're looking at 20 years worth of technology in the collection of devices you took out, and there are augmentation systems that some devices use, which bring accuracies down into more of the 3-meter range rather than the 10-meter for nominal GPS. WASP is one
Yeah,
wide area.
my U-Blocks receiver is rated as 2.5 meters GPS only, 2 meters with WAS, and 1 meter with SBAS, which is another variant on WAS apparently, but only if you can receive the signals. And there aren't
Right.
many of them. So
Right, but for SBAS, you generally need a subscription. So that's things like John Deere's augmentation system,
Yeah.
and we used to buy licenses for them at Lockheed, and they'd run like $2,000 a month.
Ooh.
but I'm now left with trying to understand why my cell phone, which is GNSS, with apparently a highly reputable receiver, seems to give very poor results. I have to work on that.
It may
And
not.
certainly my robot is no worse off than my hiking GPSs.
You got to remember these phones may not be just GNSS. As I learned from my times in the mobile phone company days, there's a chipset AGPS. So specifically for these, and they did it for E911, emergency locating. The chipsets would have the GPS radio, but then they would also take advantage of assistance from the cell tower, knowledge of the cell tower locations. So they would combine that information together and get you a much more accurate fix than you could get from just the raw satellite. If you could even see the satellite signal from indoor or whatever location you're in. So the AGPS, just by having one of these, I think.
So that thing you're waving, what is that?
This is a Apple 14 Pro Max.
I see. Okay. No, don't have one.
But it's remarkable. I mean, a 1/4 acre house that we have here, property, and it pretty much it gets an uncertainty circle, but the center of that is generally in the room that I'm in, even when I'm inside the house.
That's impressive.
So I don't know how much of that is GPS and how much of that is that this is a pretty dense populated subdivision. So there's probably a wealth of cell phone towers. So when there's that much reference terrestrial, in addition to the sky, it probably improves the accuracy a lot, I would bet, for dense areas.
Well, we shall see as I learn more about how to either take good GPS readings or find ways to do augmentation. We'll see.
Maybe you could repeat your test in an area where there's a lot of cell towers and see if you get different accuracy.
That's an interesting point because there aren't that many at the park area. It's, the park area is heavily residential to the north, but not so much east and west and south because you're into the escarpment parklands.
Sure. Yeah. Yeah, parks are that. It's always amusing to me. You go to a national park in the U.S. and pretty much within 10 feet of the border, 100, whatever, but you don't have to get more than a car length past the border and the cell phone just stops working.
We shall see. It's been an exercise. It's been education.
Okay, well, I feel like the energy is winding down, so probably time we called it a night. So thank you, everyone. Good to see you all again.
Good night.
Take care. See you next week.
Take care.
Thank you.
Good night.
Nighty night, y'all.
That's it.